Hey guys, Dr. Brown here, and tonight we're going to look at this integral, the integral of cotangent 3x raised to the fourth power. Whoa, so let's get after it. Okay, there's some things we need to understand before we get going here. We know that sine and cosine are big buddies. Why is that? Well, in this column I have f of x. The second column is the derivative of f of x. Now you'll see that sine, its derivative is cosine x. That's why they're friends. The rate of change of this function is that function. Derivative of tangent is secant squared x. Derivative of cotangent is minus cosecant squared x. Whoa. So they're best buddies, cotangent and cosecant. They're buddies, tangent and secant. They're buddies. And that's why. Now there are two identities, and we're all familiar with tangent squared x equals secant squared x minus 1. We use it all the time. I don't use this one quite so much, and that's why I want to work this problem for you tonight. Cotangent squared x, which the way I remember it, tangent squared x equals secant squared x minus 1. Now the cotangent squared x equals cosecant squared x minus 1. So just put the co in front of them and you got the same thing. Well, I mean, obviously it's different, but it sounds easy enough that you can remember that. Well, since we have cotangent and cosecant, many times, and you know this from integration of, say, a problem with sine in it. If you had a sine and a cosine, then it made the problem where, okay, I have a function and its derivative, so I can integrate that. I know how to do that. So in this case, we have cotangent to the fourth power. Oh, and I should say this. You know, that's cotangent 3x to the fourth power. But it's written as cotangent 3x to the fourth. This is the exact same as that. And sometimes I'll write it this way just for clarity, but maybe not tonight. But we could. All right, let's separate this one into 2 cotangent squared x. So we have the integral of cotangent squared 3x instead of x, 3x times cotangent 3x squared dx. Okay, now then, as we mentioned earlier, cotangent and cosecant, they're big buddies. So let's change one of these cotangents into cosecant 3x squared minus 1 times cotangent 3x squared dx. Now let's distribute that cotangent 3x into this parentheses. So we have the integral of cotangent 3x squared times cosecant 3x squared minus, and I'll tell you what, I'm going to go ahead and just separate the integrals out, minus the integral of, so this negative times cotangent 3x squared dx. So that's my minus 1 here. Now then, look at this guy. We have a function and its derivative, or a piece of that derivative, right here. So let's let u, where can we put this? Let's let u equal cotangent 3x. Let's just work with this integral first. Cotangent 3x. So du, what's the derivative of cotangent? Well, it's minus cosecant squared. So minus cosecant 3x squared. So that was the derivative of the outside. Now times the derivative of the inside. So the derivative of 3x is 3 dx. So I have minus 3 cosecant 3x squared dx. So if we isolate dx, So we would have du divided by minus 3 cosecant 3x squared equals dx. So let's substitute those items in. So now we have the integral of u squared, and I have a minus 1/3. Let's not lose that. That happens to me sometimes. All right, so that's my u squared. Now we still have this cosecant 3x squared. Dx is du over negative 1/3 cosecant 3x squared. So that's the 1/3 I had here, negative 1/3. These cancel, and I have minus 1/3 the integral of u squared du. All right, that took care of this part. Now let's work with this one. I have minus the integral of cotangent 3x squared. Well, what to do there? Well, why don't we just change it cotangent into a cosecant? But the reasoning is I can integrate cosecant squared and get cotangent. I know it sounds like I'm reaching around the back of my head to scratch my elbow, but just bear with me. Okay. All right, so let's change this here to cosecant 3x squared minus 1. So we've got that integral dx. All right, so I'm going to break that into two parts. So I have minus the integral of secant squared 3x dx minus a minus dx, so plus the integral of dx. So minus a minus dx. Now then, let's work up here. We have this cosecant squared 3x, and we're just going to work with that piece of it. Let's let u equal 3x. du equals 3 dx. du over 3 equals dx. So I have minus the integral of cosecant squared u, and du then was, so du over 3, so I'll put that 1/3 out here. All right, so that's that integral, plus the integral of dx. I'll just leave it alone, and let's work right here. All right, let's walk through our u's first. So we have minus 1/3 u cubed over 3. So we had the 2 plus 1 equals 3 divided by 3. Okay, minus 1/3. What's the integral of cosecant squared u? Well, the integral of negative cosecant squared was a positive cotangent. So if I move that negative to here, if this is positive and I take the integral of it, then I get a negative. So I end up, which I have the negative outside, so I have the negative here. So I'll end up with minus a minus cotangent 3x, and this minus a minus becomes a positive. So plus 1/3 cotangent 3x plus the integral of dx is what? It's x. All right, let's change this u to what? Cotangent 3x. So that becomes cotangent 3x cubed times 1/3 times 1/3, which is 1/9. So we end up with minus 1/9 cotangent 3x cubed plus 1/3 cotangent 3x plus x. And that, my friend, is the integral of cotangent 3x raised to the 4th power. Okay, nothing magical there, I don't guess, other than using an identity we don't necessarily use very often. At least I didn't. So I actually had to refresh my memory just a little bit. But that's why we work problems. Let's keep working them. Let's try to understand. And just it's just like shooting free throws. We need to keep shooting so that we can keep hitting them. Trust me, if you park the basketball for 5 years, those skills will leave you. Same in math. So let's perfect our skills and keep growing, okay? Why? Together we're trying to build a better tomorrow and trying to do that through math. That's all for now. We'll talk to you next time. Thanks.